Okay, greetings once again, guys, and welcome to another edition by iCampSA. In this edition, we're looking at a past exam paper for grade 12 mathematics, and that is the 2025 June exam paper 2. This was written in KZN. So we'll focus on question 5, as you can see, and question 5 covers the topic trigonometry. Okay. So let's go ahead and have a look at the question. So other questions, we'll cover them in different lessons. So for question 5, we are given the sketch as you can see here. And usually what you read here is usually what is drawn on your sketch here. Okay. So the first question reads 5.1.1 without the use of a calculator. And this here, guys, is very important. Do not use your calculator. Determine the value of y. So let's have a look at what is happening. So I'll note 5.1.1. Let's note a. So for a, we are trying to figure out what is y equal to. So what I'm going to do in order for us to figure out y, I'm just going to quickly sketch again the schematic which we have here. Okay. Because it's just easier to visualize it like this so that you can see the rationale and the thinking behind. Okay, so what you will see is that according to this, we have a negative 2 as x here. So what this means is from here to there, the distance is negative 2. Okay, and then as you can see, the distance from here to there, that has been given as square root of 13. And y is what we are looking for, which if you look at y, that would be the distance from there to there. So y is simply the distance from there to there. So now this should be very easy for you to figure out because you should be able to see that what we can do is we can use Pythagoras theorem. And with the Pythagoras theorem, what we are going to have is we're going to have our hypotenuse, which is square root of 13 all squared, equaling our adjacent side. So what I'm going to do is I'm going to put theta to be here. Okay. So it will be our adjacent side, which is negative 2 all squared. And then plus, if you observe carefully, y squared. So if you look carefully, this will end up being 13 equals 4 plus y squared. So we can transpose the 4 such that we end up having 13 minus your 4, which will give you 9. And if you think carefully about this, your y will be plus or minus the square root of 9, which means our y will be plus or minus 3. Now we need to choose the y that applies to the case we are looking at. And if you're looking carefully, this is the 0 line. So below we have negative y values. So we can just note our final answer as y equals negative 3. So let's quickly note that our answer for this question simply is y equals negative 3. Okay, done with A. Let's go and have a look at B now. So for B, if you look carefully, they say we should give them what is sine of theta. So what I'm going to do is I'm just going to take the schematic here and go and use it. Okay, because for the next question, we want to figure out what is sine of theta equal to. So remember y, which is found as negative 3. And please mind where I put the theta. So this should be very simple because we know that whenever you're thinking of sine, you should be thinking of your opposite over your hypotenuse. So if you look at where our theta is, the opposite side becomes where we had our y. So essentially, sine of theta becomes negative 3 divided by square root of 13. And this here becomes our answer for B. Okay, done with that. And then they say for 5.2.1, let's go ahead, 5.1.2 rather, use a calculator to determine the size of angle theta. So we are trying to figure out what is theta. But if you look above, we already have sine. So we have sine of theta equaling minus 3 over square root of 13. So what we can do is we can find the reference angle. So theta ref, remember with the reference angle, you just take the inverse of whatever trig ratio you have, but very importantly, you put in a positive, okay? So it will be positive 3 divided by square root of 13. So let's go ahead, 3 divided by square root of 13. So let's go ahead and use our calculator and see what is going to be our theta ref. So theta ref, all what it is, guys, from your general solution, it is your reference angle. So if you go and use your calculator, you'll find your theta ref as 56.31 degrees. Okay, that is what I find. Let me just confirm. Yep, that is what I find as my reference angle. But note that if you observe carefully, your sign, if you look carefully, is negative. Okay, in this here, we are aware that it is the third quadrant. So we understand. So now we need to translate the angle that we have found into an angle that is in the third quadrant. And what we know about angles that are in the third quadrant is that in the third quadrant, all what you simply have is usually 180 plus x. Okay, so this means that our theta will simply be 180 degrees plus our reference angle, where x here is our ref angle. Okay, so this means it will be 180 plus 56.31 degrees. So let's add 180 to our answer because it's in the third quadrant, so that you will see that your you will see that your theta will be 236.31 degrees. Okay, and this here, guys, is our answer. So just like that, we are done with the next question, which is 5.2.1. Okay, so let's move and go for the next one. So let's just move it to this page. So we're looking at 5.2. Okay, so let's have a look at 5.2, where we are required to simplify without using a calculator. So this should be very easy for you guys, but there's a couple of things that we need to note. So I'll start by quickly making some important notes. And then we go ahead and have a look at what is happening. So as part of our important notes, what I want to remind you is your special triangles. So our special triangles, if we can draw them, we have two. So we have one, like this one, and another one, like that one. Okay, let's put a 90 degrees and a 90 degrees here. So for our special triangle, we have a 30 degrees and a 60 degrees one, which is 1, 2, square root of 3. Then we have a 45 degrees, 45 and 45. So these are not drawn according to scale. And you'll have square root of 2. Okay, so for your special triangles, you should remember all your trig ratios, which is that if you look at cos of 30 degrees, which is the same as sine of 60 degrees, okay, this will be the same as, if you look carefully, cos of 30, that will be square root of 3 divided by 2. Okay, and if you look at sine of 30 degrees, which will be the same as cos of 60 degrees, I need you to remember your special, but your core ratios. You will see that this is 1 over 2. And then you'll obviously have your tan of 30 degrees, which if you look at tan of 30, you'll get 1 over square root of 3. Then we get tan of 60 degrees, of which that, if you observe carefully, it will be just square root of 3. And then you can get the same. Do the same for the other side. And you will see that we will have cos of 45 degrees, which is the same as sine of 45 degrees. Why does this work? It is because this angle here plus this angle, they add up to 90 degrees. So they form co-ratios. So these will always be equal. And this will be 1 over square root of 2. Then if you observe carefully, tan of 45 degrees, that will just be 1. Okay, that's very important. So with this in mind, plus this here, plus what I need you to remember is that whenever you're working with tan of negative theta, this is the same as negative tan of theta. And whenever you're working with cos of negative theta, this is the same as positive cos of theta. Okay, just a few things that you needed to remember. So now let's go ahead and deal with our problem. So what I usually do, I usually simplify the specific trig ratios that are there. So if you look at tan of negative 60 degrees, I know it's going to be negative tan of 60 degrees. But then I go and I remember tan of 60 degrees is square root of 3, but there's a negative, so I'm going to have negative square root of 3. So this means wherever I see tan of negative 60, I'm going to replace it with that. Okay. Then let's go for the cos one, cos negative 156. Okay. So this is going to be cos 156 degrees, of which if you observe carefully, this will be cos of, let's create some space. You will see that this is the same as 180 minus, so it will be minus 24. So what I do is I usually go to my calculator, or you just do 180 degrees minus 156. So you'll see that you needed to subtract 24. Okay. And we know that this here, 180 minus, that is in the second quadrant. And guess what? Cos is negative. So this means what we end up having is negative cos of 24 degrees. So this we really can't simplify further. So let's leave as it is for now. Let's go for the next one, where we have cos of 294 degrees. So this here, I can see that it's just above 180, okay? Or it is just below 360. So what you can do is you can think 360 is the closest. So if you say 360 minus 294, you will see that you get 66. So if you say 360 minus, you would need to minus 66 in order for you to get to that, okay? And this here, you guys are very smart. You should be able to see it is in the fourth quadrant. So in the fourth quadrant, we know cos is positive. So we'll put in positive cos of 66. Okay. So now the question becomes, how can I write this cos of 66 such that I have the 24 that I have there? And if you think carefully, you will see that cos of 66 is the same as sine of, remember co-ratios, you just need to do 90 minus whatever angle which you see there, which is 66. And this just becomes sine of 24 degrees. Okay. So this means wherever we see that, we'll just put in sine of 24 degrees. So therefore, that cos of 294, this is just the same as sine of 24 degrees. Okay. Then let's go for the last part that is on the denominator there, which is sine of 852 degrees. So you'll see that this is way above 360. Okay. And what you need to remember is that once we have a multiple of 360, this here becomes a bit simple. So you should be able to see that what we have is sine of, you can do 2 times 360 and then plus, if you observe carefully, it's 132. Okay. And whenever you have multiples of 360, you know that that's a full revolution. So what that means is we just end up having sine of 132 degrees. And sine of 132, we know it should be sine of 180 minus So think of 180 minus 132. You will see that what we end up getting is 48 degrees. Okay, so in this here, you guys should remember, this is just the second quadrant. And guess what? Sign is positive. So this means we end up having positive sine of 48 degrees. But now the question is, how can we write this in terms of 24? Because we can see that we have 24 on the others. And what we are going to do is we are going to realize that sine of 48 is the same as 2 times 24 degrees. And this here results us in using a, guess what? You guys can guess it right. This here is our double angle, okay? The double angle expression for sine. So you'll see that that will be the same as 2 times sine of 24 degrees and then cos of 24 degrees. Okay, this here is what will replace what we have there, which is just sine of your 852. Okay, so we've done the work. We can now plug back. So when you plug back, you will see that wherever we see tan of negative square root negative 60 degrees, we said there we need to put negative square root of 3. Okay, wherever we see cos of negative 156, that is just going to end up being negative cos of 24 degrees. Then wherever we see cos of 294, that ended up becoming sine of 24. Okay, and this is divided by your sine of 852, which ends up becoming what we have here, which is just 2 times sine of 24 degrees, if you look carefully, times cos of 24 degrees. And what you should be able to see is that there's terms that are going to cancel here, so that this simplifies easily. What do I mean? Well, have a look. You will see that this sign here will cancel with that sign, and this cos will cancel with the cos, and the negatives, this negative will cancel with that negative. So this means that our answer ends up becoming square root of 3 over 2. And ladies and gentlemen, that is our answer. How's that? Beautiful, isn't it? Okay, so just make sure that, guys, you are very mindful of your steps. Remember your identities, your special triangles, your simplification, including your co-ratios and the rest. So let's go and have a look at the next part of this question 5. And then this next part here is where we need to deal with simplifying. So let's zoom in. So for the first part, we are required to show that the left-hand side is equal to the right-hand side. So let's go ahead and cook this 5.3.1. So what we are required to show is just that the left-hand side is equal to the left-hand side is equal to the right-hand side. So what I usually prefer to do is to focus on the left-hand side. Okay, so let's go ahead and do so. So what we have is cos of x plus sine of x, and this is divided by cos of x minus sine of x, and then minus, if you observe carefully, cos of x minus sine of x divided by cos of x plus sine of x. So what we are going to do here is to make a common denominator. So if we go ahead and make a common denominator, you'll see we just need to multiply the two. So we'll have cos of x minus sine of x multiplied by cos of x plus sine of x. Okay. And then you will see on the numerator, what you're going to have is cos of x plus sine of x. It will multiply by this here, which is just the same thing. It is cos of x plus sine of x. And then minus, if you observe carefully what we have this side, that is cos of x minus sine of x. And this will multiply by what we have on the denominator, that is on the left part. Let's just create some space. We'll multiply by that, which is also the same as cos of x minus sine of x. Okay. So what we should be able to see is that on the numerator, we will end up having cos of x. Let's just fix this. This is plus. Yeah, we'll end up having cos of x plus sine of x all squared, if you observe carefully, minus cos of x minus sine of x. We have the same multiplying each other, so that is why they become squared. Then divided by, you will see that this is a difference of 2 squares. Okay, so that ends up being just cos squared x, or maybe let's write it this way. It ends up being cos x all squared, then minus sine x all squared. Okay, so we can go ahead and simplify the numerator because it is a difference of 2 squares. So a difference of 2 squares, we know it's just going to be cos of x plus sine of x. We add what we see, which means plus cos of x minus sine of x. Okay, that's the first bracket. Then let's go for the second one. So for the second one, we have cos of x plus sine x. We now subtract. Okay, let's create some space. When we now subtract, we minus cos, but the minus minus will make the sign to be positive. So it will be plus sine x. Okay, like that. And this is divided by cos squared x minus sine squared x. Okay, so let's go to the next page and see how this simplifies. So let's look at the numerator. So on the numerator, you will see that there's terms that are going to cancel. So sine and sine will cancel on this bracket, and cos and cos will cancel. So we'll end up being left with, if you observe carefully, 2 cos of x, and that will multiply sine and sine. So we'll have 2 sine of x. And if you observe carefully, this is dividing by cos squared x minus sine squared x. When we get here, I need you to remember something. And this has to do with your double angle expressions. So I need you to remember the double angle expression for sine. So if you have sine of 2x, this is the same as 2 sine of x cos of x. So meaning, as long as you have 2 times sine of x cos of x, that can be written as sine of 2x. But let's have a look at another double angle expression for cos. So for cos, I need you to remember that cos squared x minus sine squared x, that is a double angle expression for cos, or for cos, you can also have 2 cos squared x minus 1. That is another double angle expansion. You can also have cos of 2x equaling 1 minus 2 sine squared of x. So you will see that for our problem, what will happen is I'll put up one of the 2 outside, then I have 2 sine of x cos of x. Okay, and that is divided by cos squared x minus sine squared x. Okay, so you will see that for our problem, we'll now have 2 sine of, on the numerator, we'll have sine of 2x, Then on the denominator, we'll have cos of 2x. And you will see that this becomes sine and cos dividing with the same angle. That becomes tan of that angle. Okay. And this here, guys, is what they needed us to show. So that there is our answer. Okay. So I hope that you do understand and you follow all the steps that we undertook here. So let's go to the next page and have a look at the second part of the question. So the second part of the question requires us to determine for which x values is 2 tan of x undefined. Right, let's go. So we're looking at 5.3.2. So the question is, for which x is that undefined? So one thing that I need you to make as a note whenever dealing with such questions is that whenever we speak of undefined in your, what you call it, in your trig, what essentially we want to evaluate is, let's say, a division by 0. Okay. Once we have a division by 0, that is where we have an undefined. So what do I mean? If you look carefully, we have 2 tan of 2x. And this can be written as 2 sine of 2x divided by cos of 2x. So what this means is we need to make cos of 2x to be equal to 0 to get the values that will make this to be undefined. So we need to make our cos of 2x to be equal to 0 so that we have division by 0. And this will give us the x values that will make this to be undefined. So let's go ahead and have a look at cos of 2x equals 0. So what I'm going to do is to quickly sketch a graph for cos for us to just be up to speed with what is happening. Okay. So if you do remember, you'll remember that cos is a graph that looks something like this. Okay. Then going to the left, it is something like that. So you will see, where is it 0? Well, it is 0 here at 90 degrees. It is 0 here at minus 90 degrees. And it is also 0 here, that is at 270. And this here, it would be at 270. And this carries on and on. Okay. So let's go ahead and do this. So you'll see that your 2x will simply be your inverse cosine of 0 and then plus k 360. Okay. So we'll have our k 360 degrees. And you will see that we will use a reference angle of 90. We can use minus 90, it doesn't matter. So 2x will be, if you look carefully, we'll just use 90 plus k 360. Okay. Then we can divide by 2. But with cos, what you need to remember is that if you are looking for the general solution, what you can do, you can actually use plus or minus. It makes no difference. So you'll see that your x will be plus minus your 90 degrees. This will be divided by 2 plus k 360. And this will be divided by 2. And you will see that the x value will be plus or minus 45 degrees. Then plus k 180 degrees. Okay. So you can leave your solution as such, or you can give them a couple of answers. Let's see if they restricted our x values. So they really did not. So maybe let's do for k is 0. So for k is 0, you will see that we can have two answers. We are going to have an x equals 45 degrees and then x equals minus 45 degrees. Okay. And then for k is 1, you will see that we'll get two x values. So you'll have an x value of 180 plus your 45, that will be 225, okay, degrees. And you'll see that for when this is minus, that will be the same as 180 minus 45, which will give you 135. Okay, and you can carry on and so on. This will just be differences of 180 degrees. Okay, so that is what they were expecting us to do. Essentially figure out when is tan undefined. So someone else would have said tan is undefined at 90, to make the life easy. Then they know that the angle here must be 45. So even this here and that for others would have been enough. Okay, so let's move to the next question, guys. The next question is this one. Let's take it to the previous. Well, let's keep it here. So we are told if cos of 40 degrees equals P, determine the following in terms of P without the use of a calculator. So let's go ahead and cook. So we're looking at 5.4. And what we are told is that cos of 40 degrees equals P. What we prefer is to always write this such that for the adjacent, for cos we have the adjacent over our hypotenuse. This is very important. So that there becomes our adjacent side. And what is dividing here becomes our hypotenuse. Okay. And guess what? We can now try and figure out the very important part, which is what is our opposite side. So we know that according to Pythagoras, we know that the hypotenuse squared is the same as the adjacent side squared plus our opposite side squared. Okay. Now, if you observe carefully, you'll see our hypotenuse is 1. So we have 1 squared equals our adjacent side is P. So we have P squared plus our opposite side squared. So we can transpose and have our opposite side squared equaling 1 minus P squared. And you will see that our opposite side will end up being square root of 1 minus P squared. Okay, so that is what we have, guys. Now we need to go and deal with the next question. So what I prefer to do after we are done with this is to quickly draw a sketch, rough one, for what is happening. Okay, so we need 90 degrees. And let's go ahead and label. So we have a 40 degrees angle. So the other angle, to make 180 here, you can just say 180 minus 90, then minus 40. You will see that you get 50 degrees there. Okay. Then let's put these in. So our hypotenuse is 1, our adjacent is P, our opposite is 1 minus P squared when we're standing at 40 degrees. So now let's go ahead and cook, see what is happening. So we are asked to figure out, without using a calculator, cos of 10 plus cos of 70. Okay, this is very interesting. So let's go ahead and deal with that. So we need to figure out what is cos of 10 degrees plus cos of 70 degrees. So we need to ask ourselves, using our angles that we have here plus our special angles, how can we deal with this? So what I need you to remember, whenever you're solving such questions, special angles are usually hidden somewhere here. Okay. So when I look at 10, I can see that I can use 30 and 40 to get 10. Okay. So which means wherever I see cos of 10 degrees, I can write this as cos of 40 degrees minus 30 degrees. So I've managed to figure this thing out here. Okay, and then what about cos of 70? So if you look at cos of 70, we can do exactly the same thing. And that is, if you look at cos of 70 degrees, we can say that this is the same as cos of 40 degrees plus 30 degrees. Okay. And this, we are going to go to the next page and quickly work out. So wherever we see this here, we just need to also remember our compound angle. So let's quickly note it down. So we need to remember what we call our compound angle identities. And the one which we need for this is cos of alpha minus beta. That is the same as cos. Let's just use A and B, zoom in. So where you have your cos of A, let's start with plus B, okay? So this becomes cos of A, and then cos of B. Then minus, very importantly, sine of A, and then sine of B. Then we also need cos of A minus B, okay? And this becomes cos of A, then cos of B plus sine of A, sine of B, okay? So if you observe carefully, we will be adding these, okay? And if you observe carefully, if we do cos of A plus B, and then plus cos of A minus B, this here will end up giving you 2 times of this. So we'll end up getting 2 times cos of A and cos of B. Okay. What am I getting into? Well, if we go ahead and do cos of 10 degrees and then plus cos of 70 degrees, you should be able to see that this is the same as cos of 40 degrees minus 30 degrees plus cos of 40 degrees plus 30 degrees. Okay. What this means is our answer will become, if you observe carefully, it's exactly the same setting. Okay. Our answer will become 2 times cos of 40 degrees and then cos of 30 degrees. Okay. That is what it will become, of which this then becomes cos of 40 degrees. If you observe carefully, that is simply P. So we have 2 times P over 1. And then cos of 30 degrees, let's quickly draw our special triangle somewhere here. Let's go ahead, the 31. Okay, let's make 90 here. And you should remember you have 30 degrees, then 60 degrees, then 1, 2, square root of 3. So you'll see that your cos of 30 that is the same as, let's create some space here. Your cos of 30, which is just your adjacent, that's just the half. Okay. So you'll see that this will end up multiplying by 1 over 2. My apologies, square root of cos of 30 degrees is square root 3 over 2. Let's quickly fix that. Square root 3 over 2. So this will be square root 3 divided by 2. And what you will see is the 2's will cancel, therefore giving us an answer which is square root 3 times P. And this here, guys, becomes our answer. Okay. Hope you guys understand the rationale here and the thinking. Very simple question, just apply yourself. So let's have a look at this question now. So we are required to solve for x in the interval negative 180 to positive 180. Okay, so let's go ahead. We're given that 4 sine x times cos x, that should be 3 sine squared x. So what I'm going to do is to transpose such that I'm going to have 4 sine x cos x minus 3. If you observe carefully, sine squared is simply sine x equals 0. And what you will see is we have a common factor of sine. Okay, so we can pull it out. So we can have sine x into 4 cos x, then minus 3 sine x equals 0. And guess what? Our solution becomes sine x equals 0, or 4 cos of x minus 3 sine x, that equals 0. So I'm just going to focus on this element this side, which then becomes 4 cos of x equals 3 sine of x. And what I'm going to do here is to divide by sine on both sides. Okay, so that is what I'm going to do. Let me just move this to here. So that's what we are going to do. And if we do that, you will see if you divide by sine on, in fact, we should divide not by sine, but by cos. Okay, so that we can make it to be a tan. So divide by cos x on both sides. So if you divide by cos x, you will see that we'll end up having 4 equals 3 tan of x. And then you will see that we'll end up having tan of x equaling 3 over 4. Sorry, it's actually 4 over 3. So tan x will be 4 over 3. So we now have two solutions. We have sine x equals 0, or we have tan x equals 4 over 3. Okay, so let's go ahead and find our reference angle. So that's our inverse sine, and we are also going to find our reference angle even here. And that is just the inverse of tan of 4 over 3. Okay, so let's start with sine. So if you go and you shift your sine, you will see that what you will end up getting is your 0. But let me quickly remind you of how the sine graph works. Okay, so if we can quickly have a sketch here. So you should remember that your sine graph looks something like this. Okay, then it goes back like that. And what you should note is at this point here, it is at 180. That's where it is 0, and 360 here, and 0 here, and at minus 180 there. Okay, so you will see that our reference angle there, it can be 0, but we know that sine is 0 at multiple points. Okay, so which means we have x values which are 0, and we also have an x value at 180 because it's still within the limit. 180 is included, it's only negative that is excluded. Okay, so which means we can also have x 180 degrees. Then let's have a look at tan. So for tan, we'll have our reference angle being equal to, I'll go to my calculator, shift off 4 over 3. Make sure your calculator is in degrees. So we get 53.13 degrees. Okay, but we need to remember, where is tan positive? Tan is positive, if you remember, in the first quadrant and the third quadrant. Okay, so now we need to figure out which other angle works here. So remember, then we need to go to our general solution, which is x equals our reference angle 53.13. We're dealing with tan, so we're going to have k 180 degrees. Okay, So if you observe carefully, we can do k equals minus 1. If we do k is 1, it will be above that. So let's go and try k equals minus 1. So if you go to your calculator and say 53.13 plus you put minus 1 times 180, you will see that you will get an angle which will be negative 126.87 degrees. Okay, so that becomes one of our answers. So it means we have that as our answer, and we also have an x value that is 53.13 degrees. So these here become our answers. This one, this one, this one, and this one. Okay. I hope you guys understand. Just make sure that you do revise your general solution and you have a good idea of how these graphs look and how they work. Okay. Hope you guys understand. Next, we'll have a look at 5.6. Let's see, can we move it? Maybe not. Right. So let's have a look at what is happening here. So we are told that tan of theta equals m in a right-angled triangle. Now we are required to show that sine of 2 theta will be equal to that. Okay, let's go and have a look. 5.6.1. So what we are starting with is tan of theta that equals m. But what I'm going to do is I'm going to need to see what is my opposite and what is my adjacent. Okay, so this here is very important because that numerator there becomes our opposite side and that denominator becomes our adjacent side. And guess what? We are looking for now the hypotenuse because we'll work with sine. So according to Pythagoras, our hypotenuse side squared will always be given by our opposite side squared plus our adjacent side squared, which means m squared plus 1 squared. So you will see that our hypotenuse, therefore, will simply be the square root of 1 plus m squared. Okay. Now, if you observe carefully, we are given sine. So we want to show that sine will be equal to that sine of 2 theta. It will be equal to that. But what I need you to remember is that sine of 2 theta, according to your double angle expressions, it is 2 sine of theta cos of theta. Okay. And we can go ahead and figure this thing out. What is 2 sine of theta cos of theta? Well, if you go and look at our setup, you should be able to see that sine of theta, remember sine is opposite over the hypotenuse. So our opposite is m. Our hypotenuse is what we just found now, square root of 1 plus m squared. Okay. And then we can go and have a look at our cos. So you will see that your cos of theta, cos, remember, is adjacent over hypotenuse. So adjacent is 1. Our hypotenuse is the square root of 1 plus m squared. So this means that our 2 sine of theta and then cos of theta, that's the same as 2 into m divided by the square root of 1 plus m squared multiplied by 1 divided by the square root of 1 plus m squared, of which, if you observe carefully, those square roots on the denominator will multiply. Okay, so you will see that our sine of 2 theta will therefore be 2m on the numerator. On the denominator we'll have 1 plus m squared. And this here, ladies and gentlemen, that is our answer. Okay, very simple question. Now let's go ahead and have a look at the next question. which is 5.6.2. So they are asking us, hence otherwise, determine the maximum value of that, the maximum value of this expression. So we really need to think carefully here. So we need to be careful here. So let's go ahead and have a look at what is happening. So we are looking for the max value. So others would go and try and use their calculus skills, but what I'm going to do is very simple. We have m plus 1 all squared divided by m squared plus 1. So if you expand the numerator, you'll see you'll end up getting m squared plus 2m plus 1 divided by m squared plus 1. And if you look carefully, you can separate this. You can have m squared plus 1 divided by m squared plus 1, then plus 2m divided by m squared plus 1. So you'll see that this is 1. And what I need you to remember is that this portion here is the same as sine of 2 theta. Okay, so this will end up in 1 plus sine of 2 theta. Now the question becomes, now this is very simple, what is the maximum value of this? So you should be noting the amplitude here, because your sine graph can be as big as the amplitude. So this means that the maximum value will be 2. That's it. So our answer for this question is that the maximum value is 2. Okay, this was a very simple one, guys, and I hope that you all understand. Okay, it looked a bit tricky, but it was nothing deep. So that brings us to the end of question number 5. I hope that you guys understood and you would be able to answer all the questions if you were writing this paper. Engage, please like, share, and spread the good gospel of passing. Cheers, guys.